Listen, enough Muntasim, Shubham, don't spoil Muntasim. Okay. Alright. Okay, pay attention. So I was discussing that how to, that the aim of this experiment was to see my teaching effectiveness, right? So I need to take my samples. The samples are students, and I'm conducting a blind test on the students, right? In this sample, I need to consider few factors. First factor is it should be a mixed sample. It should not be only dry, only Einstein, or only superstars. It should be everyone, right? Then second criteria, sample size. Can I take only 3 students? Einstein, supersmart, plus ultra smart. Only 3 students. Can I judge my effectiveness with 3 students? It's not possible. I need more people, more Einsteins, more super smarts, more ultra smarts. Got my point? So I need more sample. Sample size matters. Sample quality matters. When I say quality, that is Einstein super smarts. And when I say size, the number of students. Is it clear? Now I will conduct a blind test. This test will be 2 types. Let us assume a hard test and a simple test. A simple test. So my sample has, all of you are my samples, a mixed population with a larger sample size. Got it? So now we decided our sample and I'm going to conduct a test. Okay? Let us assume, students pay attention, this will be really interesting. I'll combine 2 important topics here. Okay? Listen, my test comprised of 12 marks. I'm going to conduct a 12-mark test to you, a 12-mark quiz to you. Okay? The quiz of 2 types of quizzes are there. Actually, surprise test 3 and surprise test 4. There are 2 surprise tests today actually. Let us assume. Don't worry. Okay. An hard test and a simple test. Okay? Now, let me keep a margin in mean value. I cannot expect 12 out of 12 from all of the students. It's not possible. Am I correct? Can I, what will be the very good number you give me students? Can I say 7? 7 will be achievable by everyone. Most of the students can achieve 7 marks. Am I correct?
Yes.
Most of the students can achieve 7 marks. In case of simple test, I can rise my margin. Right? Maybe can I keep 11 marks here? Or 10 marks. Let us keep 10 marks, okay? Taking care of our anyway. Yes. Now 10 marks and 7 marks. Don't take it personal, okay? Sorry, I'm not supposed to say names. Anyway, listen. Got it? So, my target value, I'm writing here in a technical term, maybe I will say it as a like this. My target value, assume that is 0. Target value here 0 means 10 marks. Here target value is 7 marks. Okay, target value is 7. Okay, now there will be some range, plus or minus 1 or 2. Okay, plus 1, plus 2. This is the range here, 12 marks, 11 marks, 12 marks. Here, plus or minus 2 again, minus 1, minus 2. Now see, in this criteria, that means 10 marks, 9 marks, 8 marks. I know that most of you will achieve my mode. My target value, this is my mode. My target value is just 10 marks, and I know that most of you, okay, here this is frequency, number of students achieving the target value, number of students achieving target value. Here is the total number of students. Okay, I know that most of you will get 10 marks, and few of you will get around this range, 8 to 12. And very less students will get less marks. When I plot it, I got a standard deviation. In 12 months with a target of 10. I can also plot an expected standard deviation in 7 mark also. I will keep target 7 here, board as a 7, and I will keep 10 marks as the highest score and 6 marks as the lowest score. I can even get here also, I am getting a standard deviation, even the hard test. In the hard test, I lowered my expectation. In the simple test, I increased my expectations from the students. Okay? This type of grading is called as relative grading. This is called as relative grading. And other one is absolute grading. I will tell what is absolute grading and relative grading. Absolute grading means in the 20-mark exam, whomsoever got more than 18, they are smart. Less than 18 are slow learners. Okay, not smart students. That is called absolute grading. Irrespective of my subject, I might be teaching quantum mechanics to you, but I kept my standard as a 18. Only 18 will be smart. Less than 18 is dumb. That is not a good thing. Absolute grading is not a good thing actually. And can anyone guess what grading we are using in this university? Will it be an absolute grading or relative? Okay, I will tell what is relative grading. Relative grading means, first of all, sorry, actually, this is not yeah, where am I? Relative grading. What is relative grading? Listen. I kept a quantum mechanics subject. Okay. Obviously, quantum mechanics is tough. So I need to first of all I will evaluate all your marks. After evaluating your marks, I came to know the smartest student got 10 marks instead of 12 or 20 marks. The smartest student got 10 marks instead of 20. Now 10 I will take, and I will take mean of 10. Maybe I will take 6 as a mean range for this particular exam. Whomsoever student getting 6 are the average students, whomsoever getting 10 are the super smart. This is called as relative grading. Okay, that is what we will do in the universities actually. Your CGPA is calculated based on relative grading of your entire class. Personally, if you see only your marks, you will feel like you should get a very good CGPA. But when you won't get an expected CGPA, because that CGPA will be graded based on your complete class strength actually. How many smarts, not smarts, middle are present. So that is the best method of evaluating the students. Why we are going with the relative grading? Because not in all classrooms we will have same strength. In the masters we have only 10 students. So we need to keep some competition among 10 students. So we will see among them. The competition will be among them. That is called relative grading. What my point? I cannot keep an equation of 10 with a 50 equation, 50 formula. Definitely all of them will be, slow learners. So I need to consider, I need to adjust the formulas. Got it? Yeah. Now we understood what is standard deviation, the significance of standard deviation. Got it? Now, coming back to the point, hard and simple test. Listen, it's okay. Hard and simple test. What I will see is, this is the expected value and this is the variation. Okay. In case of hard test, the variation might be high. Am I correct? In case of hard test, there will be more variation. Right? The variation will be very high in hard test, but the variation in simple test will be very less because everyone knows the answers. What my point? Yes, sir. The variation will be larger variation, smaller variation, and this is called standard deviation. Now we will really conduct an actual test of hard test and let us see the variation of hard test results. Okay, so surprise test 3 is a hard test. Everyone go to the first question. Let us see. Let us see the variations, okay? Yeah. 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 Then third question. Third question. What is the normal age of hemoglobin in males? Fourth question.
What blessed?
Huh? Yes. Yes, class enough.
I made a mistake. I put answers in the
Down,
places.
6A.
Class.
Okay.
Class point everyone.
Huh?
Ronald Sakshi point.
5 is
Nisha point.
So,
So now we have conducted a test. Am I correct? A hard test and a simple test. What is the expected variation in the hard test? More or less?
average.
Hard test variation more, because standard testing histology is steady, whereas simple test the variation will be very less because everyone knows the answers. Am I correct?
No.
So this should have a very elongated SD, whereas here we will get a let us see. It's okay. Don't worry. Don't worry about technical error. I will see that. Don't worry. Let us see the results. Let us see the results. Okay. Let me open the results on the board. Yeah. So see the results. Test 3 versus test 4. So this is the test 3 results. 53 students participated. Another one, test 4 results. So can anyone say what is mean means? I need to take a mean value from your classroom. Okay? So it will be sum of all values divided by total number of students. That means sum of all by 53. Okay? Let us see here. So let us see the standard deviation of surprise test 3. See here students, I want a standard deviation. Yeah, here. There is a huge variation here, and these students have a other skewness. So this is a positive skewness, these are cheated or highly performed students. Okay. Whereas here we can see if I take this as a what test is this?
Sorry, hard test. Hard test.
Hard test. Yeah. In the hard test, if I take 7 as my mean, as I take in mean 7, see, most of the students are in 7, as expected.
Yes.
Most of the students got 7. Then the variation is very high. Maybe positive or negative, variation is very high. Okay? Variation is very high here. This is the target value. Okay. Let me show you the values also there. See, 7 students got high value and these are small test students. So actually this is now showing a positive skewness. Why positive skewness happened? Because most of you cheated. Due to cheating, this is positive, this is negative. Positive skewness of data happened because of cheating. Okay? See, just by seeing the graph, I can assume what's going on in the classroom, and I can see the overall status of the students. First of all, I am really failed in this test because most of you didn't understood the topic. There is no, variation is very high. Either you cheated, that's why you understood, and high variation that indicates lack of understanding of the concept. And positive skewness because of cheating actually. Okay. positive or negative. This indicates I was the best teacher or I conveyed best in basic hematological parameters or test 4, but I didn't convey properly the test 3 topics. As expected, yesterday we studied karyotyping, but this one we already know since 1 year. See, just with data we understood the concept, we evaluated my teaching efficiency with a simple test and a hard test. So in order to perform these standard deviation calculations, we need more mean. Mean means the average value of a classroom. Then we need the most commonly happening values in the classroom. Most commonly appearing values will be the median values in the classroom, and the mode will be the difference between high and low. Okay. So if we get these 3 data, we can start using the we can plot the variation. This one, okay, tendency of variation. This is called a central tendency or standard deviation. There are 3 types of central tendencies. A central tendency, then a positive skewed data and a negative skewed data. Okay, negative skewed data means most of the students will fail or they are getting less, the average value will be less scores. Whereas in positive, the average value will be high scores. Positive skewed, average values will be very high. Whereas in negative skew, average values will be very less scores as an average. Okay. So this is what exactly we are studying in statistics actually. Mean, median, mode, and the applications of mean, median, mode in understanding my effectiveness, my delivery. How we can use this mean, median, mode in lab tests. Just like this data, let us assume the quality of the instrument. Instrument should give the right values. Okay, the correct values. It should not give error values. If there is a randomness in its performance, it is useless. So, for quality control to test any efficiency, we must utilize the statistics. Statistics will be very helpful to understand large amount of data and the quality of the data which are generated. Whether the data is accurate or not. You understood? I think I given a simple explanation of your research methodology, right? And that is why you are studying this in research methodology. You can able to understand the unknown parameters, that is research, right? Yeah. And methodologies. What methods we can use to do research to understand the unknown parameters and to get a proper distribution of the data. Unless and until your data showing SD, that is not a right data. That's why in research we are using something called p-value. P-value is it should be 0 to 0.5 or less than 1. If the p-value is greater than 1, that indicates your research is useless. There is no proper connection between your hypothesis and the idea. Maybe I will discuss about p-median more in the next lecture. Anyway, you got some idea? Yes, sir. Experimental evidence with your marks. And I want to show you one interesting parameter in your results. When I say the hard test, or simply I can say time parameter, in the first test, the time is very less and I initiated the test. So the total number of students attempted the test is less. Okay. See, now it became 53. And let us see the simple test, that is 46. Alright. So most of them become vice versa. Yes. Okay, Shubham, you give me attendance, okay, after this class. Okay, thank you, class.